Welcome to more derivatives of inverse functions. So just a quick recall. Recall that if we wish to take if we have an invertible function f and we wish to take its derivative at x, then this is equal to 1 over the derivative of f evaluated at f inverse of x. Now also recall that if that f and f inverse work sort of undo each other. So if f sends a to b, then f inverse sends b back to a. So in other words, if f of a is equal to b, then f inverse of b is equal to a. So if we work with these, right, then what we get is we could evaluate f inverse prime, the derivative of f inverse, at b. And this is the same as doing 1 over f prime evaluated at a. So we're going to take this and just work with some specific examples. So consider the following information about the invertible function f. So f of x is equal to negative 2x squared plus 8x minus 3, and it's defined only for x greater than or equal to 2. We need that piece for f to be invertible. And then we're also told that f of 4 is equal to negative 3. And our job is to find the derivative of f inverse evaluated at negative 3. So this is precisely the same thing as 1 over the derivative of f evaluated at f inverse of negative 3. Just by definition, or by that rule we have. And then if f of 4 is negative 3, then that means that f inverse of negative 3 is 4. So what we have is that the derivative of f inverse evaluated at negative 3 is the same as 1 over f prime evaluated at 4. Right? So we're just taking f inverse of negative 3, and we're told, well, that's equal to 4, so we've replaced it with 4. So at this point, we need to know f prime. So we need to find f prime of x. Well, f of x was negative 2x squared plus 8x minus 3. So f prime of x would be power rule. We do negative 2 times 2x, or negative 4x, and then plus 8. And therefore we have f prime of 4. We have negative 4 times 4 plus 8. That's negative 16 plus 8, or negative 8. So now we can go ahead and plug in. I need to give myself a little more room. If we plug back in, again, what we had f inverse prime of negative 3 was equal to 1 over f prime f4. And then this is just 1 over -8. So we got the derivative of f inverse evaluated at -3 is -1/8. So let's go ahead and do this for one more function. So we have the following, consider the following information about the invertible function g. G of x is equal to x cubed plus 7. G of -1 is therefore equal to 6. And our job is to find g inverse prime of 6. So again, first thing, let's go ahead and write g inverse prime in terms of g prime. So again, we know that g inverse prime evaluated at 6 should be 1 over g prime of g inverse of 6. Next up, let's go ahead and find g inverse of 6. So we're going to use the fact that g of -1 is equal to 6. G inverse just goes the opposite way. And so we have g inverse of 6 is -1. So if we plug that in, we are looking at the derivative of g inverse evaluated at 6 is equal to 1 over g prime evaluated at -1. Again, g inverse of 6 is equal to -1, so we plugged in -1. At this point, we need to find g prime. Of x, or we need to find g prime of -1. So we know g of x was equal to x cubed plus 7. Therefore, g prime of x, if we use the power rule, we should be looking at 3x squared. And we are interested in g prime of -1, or 3 times -1 squared, which is 3. So now we'll one more time go ahead and plug in. And we had the original g prime. So g inverse prime of 6 was 1 over g prime of -1. So we have the derivative of g inverse evaluated at 6 was 1 over g prime of -1. So that is equal to 1 over 3. So this is just a little more practice of finding or evaluating the derivative of the inverse, knowing information about the original function.